Alright, so cell respiration is broke up into 3 steps. Glycolysis is the first one. So what happens here is we have glucose, which is a 6-carbon molecule. Alright? Now, glycolysis starts because 2 ATP are used to power the splitting of this 6-carbon chain. So now, these become 2 separate 3-carbon atoms known as pyruvate. Now, this is not the only thing that happens. So, because of this split, there's enough energy now to cause these 4 ADPs and these 4 organic phosphates to phosphorylize and become ATP. So now there are 4 ATPs created by glycolysis. But because 2 are used, you only have a net gain of 2 ATPs. And because of this split, there are now electrons chilling out just kind of by themselves. But in order to be taken care of and picked up, we use NAD, as our electron carriers. Now these come in here, pick up these electrons, creating NADH. So now, the final products of glycolysis are 2 pyruvate, 2 NADH, and 2 ATP. Now, because glycolysis took place in the cytoplasm, we now need to move the reactants into the mitochondria. So, what happens is the CoA enzyme is what transports the pyruvate into the matrix of the mitochondria. But it also decarboxylates the pyruvate, leaving these 2 carbons by themselves over here. And so the CoA enzyme is what transports this into here. And once these 2 carbons are now in here, they are now known as acetyl-CoA. Now, we have the acetyl-CoA made, but we also have these electrons that are loose and these carbons that are loose. So, in order to take care of the electrons, we use the NAD like usual. These come in here, pick up these electrons, and move them back. And this creates 2 NADH, of course. And then because of these carbons, they bond with oxygen, making CO2. And it makes 2 CO2 because there's 2 carbons. So, the products of link reaction are 2 acetyl-CoA, 2 NADH, and 2 CO2.